In this video, we'll briefly look at reviewing polar coordinates and some equations. Up first, we want to plot the following coordinates. I don't have a polar grid here, so we'll just have to kind of envision what's happening. We have the polar axis, which is essentially the positive x-axis, and we're opening up an angle of pi fourths. So that's roughly here. There's our theta, pi fourths radians, and the r in this case is 5. So starting at the pole, we'll count out 1, 2, 3, 4, 5 units away to get us to the point 5 pi fourths. Just as a review, if we wanted to see that in the Cartesian plane, x and y coordinates, recall that x is r cosine theta. That means we have 5 cosine of pi fourths. Remember your unit circle, cosine of pi fourths is root 2 divided by 2. So we get an x coordinate of 5 square root 2 divided by 2. And then y is r sine theta. So we have 5 sine of pi fourths. That is 5 times the sine of pi fourths is root 2 divided by 2. So we get, again, 5 square root 2 divided by 2. Meaning that this coordinate, or this point, in rectangular form would be 5 square root 2 divided by 2, comma, 5 square root 2 divided by 2. In the next example, we're looking at -2, 5 pi 6. Again, let's get a quick sketch of where that is. 5 pi 6 is somewhere over here in quadrant 2. There's our theta. And r is actually negative, so that's going to push us down into quadrant 4, 1, 2 units. So we have this point, -2, 5 pi 6. Again, if we wanted to convert those to rectangular coordinates, x is r cosine theta. In this case, -2 cosine of 5 pi 6. That'll be -2 times, let's see, the cosine of 5 pi 6. That is negative square root of 3 divided by 2, which will give us negative root 3. Y is r sine theta. -2 sine of 5 pi 6. That is -2 times, let's see, that's 1/2, which will give us -1. That means the exact same point in rectangular form would be negative square root of 3, comma, -1. And now we'll look at converting polar equations back into rectangular form. It can be helpful to recall some of the formulas that we use to do some conversions. Let's first talk about those. We have x squared plus y squared equals r squared. We also have x equals r cosine theta. And we have y equals r sine theta. And remember, when converting from polar into rectangular, there's a couple tricks we can use that typically work, not always. But one thing we could do is multiplying by r on both sides. If we multiply by r on the left, we'll get r squared, which is convenient. But on the right, we'll have 4r. We'll have this leftover r that doesn't really help us. So the second thing we can do is square both sides. Which will help us in this case. If we square the left, r times r is r squared, and if we square 4, we get 16. We can then replace r squared with x squared plus y squared. X squared plus y squared is equal to 16. We now have the rectangular coordinates, or the rectangular equation rather. Hopefully we recognize that this is a circle centered at the origin. 0, 0. And then the radius of this circle is the square root of 16, which is 4. So if we wanted to sketch this, we could. Go 4 in every direction from the center. And it's a semi-decent looking circle. A little wobbly there at the bottom. Notice in the original equation, you don't see a theta. All we see is r equals 4. That means theta, the angle, can be anything. And no matter what that angle is, the distance from the pole or the origin is 4. So if we go 4 units away from the pole, we get a point here. We could go up. We could go left. We could look at this point. No matter what that angle is, the distance from the pole is always 4 units. In our next example, we have r equals 3 secant theta. Again, the typical tricks we use are try to square both sides. If we square the left, we get r squared, which is good. If we square the right side, we'll get 9 secant squared theta. But that's not really going to help us because we want to convert to rectangular form. Another way would be to multiply by r on both sides. Again, multiplying by r on the left would give us r squared, which would work. But on the right, we get r secant theta, which we don't have a conversion for. So we can't use one of the two typical techniques. If that's the case, let's see if we can simply rewrite the equation. R equals 3, and think about secant theta. Secant theta is 1 divided by cosine theta. And at this point, we still want to remove that cosine out of the denominator, so we can multiply by cosine theta on both sides. On the left, we have r cosine theta, and on the right, we have 3. And recall, r cosine theta is simply x. We have x equals 3. We now have the equation in rectangular form. And recall what that looks like. X equals 3. Notice you don't see a y. It's just x equals 3. That is a vertical line through the x-intercept of 3.